Friends, in this video, let us see the problems on mass pulley system, Atwood's machine. So the first question is, two blocks of masses W1 and W2 are suspended from the ends of a light string passing over smooth fixed pulley. If the pulley is pulled up with the acceleration G, then the tension in the string he is asking to find. Okay, what he said. So pulley, okay, this pulley is fixed to one end on same string. He suspended, he is not changing the string. At the both ends of the string, he suspended two blocks of masses W1, okay, and W2, right? Now next, he is saying if this pulley is lifted upwards or up with acceleration G, if this pulley is lifted upwards with acceleration G, then he is asking to find the tension produced in the string. So now first, now the tension produced at this side due to this block of mass W1 is T. Remember that always the tension will be away from the body, and the tension produced due to W2 is also her T. Why I am writing the same tension? Remember two things. One, tension will be always away from the body. The second thing, until the string does not change, tension will be same. Here, same string. So tension is also same. If string changes only, tension will change. Right? Now next, gravity. Gravitational weight, let it be M1G, acts in downward direction. Here M2G acts in a downward direction, right? Gravitational weight. Okay, now next. Now he is asking to find the tension. So first, let us write the motion of mass M2 for this body. Now how it is? Now here let us assume that W2 is greater than W1. So when W2 is greater than W1, what happens? This pulley will come in such a way, no? And this comes down. W2 greater, no? It comes down and it comes up, right? So now for this, the greater force is M2G and W2 compared to the tension T. So now what we will write? W2 then plus M2G. Both are in same direction. Tension is opposite to this. So minus T. And according to Newton's law, second law, this must be equal to M2A. Right? But M2G, nothing but gravitational weight. So I am writing as W2 minus T is equal to M2A. So this becomes 2W2 minus T is equal to M2A. Right? Put it as equation 1. Now let us write for mass M1. Okay. Now here the pulley, this is moving in upward. This is coming downwards. So M2G is the greater force here, W2 and M2G. But this is going in upward direction, means the greater force here is T compared to these two forces. So what we will write? T minus W1 minus M1G, opposite direction, no? So minus. According to Newton's second law, this must be equal to M1A. So T minus W1, I can write this as gravitational weight W1, that is equal to M1A. So T minus 2W1 is equal to M1A. Put it as equation 2. Alright? Put it as equation 2. Now next, add 1 and 2. So what is 1? 2. W2 minus T, LHS, LHS, RHS, RHS, plus T minus 2W1 is equal to M2A plus M1A. Right? Now, what happens? So, TT strikes off here, minus T plus T. Okay? Minus T plus T. Now, what remained? 2W2 minus 2W1. So, 2W2, here I will write, minus 2W1. This is equal to, here what is there? M2 plus M1. I can take A as common. M2 plus M1 into A. Right? Now, next, we know that W1 means what I wrote? M1G. So from this M1 I can write it as W1 by G. W2 what I wrote? M2G. So in place of M2G I wrote W2 now. So M2 I can write as W2G. Now put these both here. So what you will get? 2W2 minus 2W1 is equal to W1 by or W2 by G plus W1 by G into A. Now G as LCM, right? G as LCM. So now what I will write? I want the A value. So see, 2W2 minus 2W1 is equal to W2 plus W1 by G into A. But I need A. So A is equal to, what happens? G 2W2 minus 2W1 by this one, W2 plus W1. I wrote this equation in terms of A. Okay. Now I got A. Now put this A, equation 3, in equation 2. So what is equation 2? T minus 2W1 is equal to M1A is the equation 2. A you substitute here. T minus 2W1 is equal to M1. What is A? G 2W2 minus 2W1 by W2 plus W1. Right? Now send this 2W1 to this side. So what you want to find out? You have to find out tension in string when pulley is raised up with acceleration G. So now T, this is equal to M1 G 2W2 minus 2W1 by W2 plus W1 plus 2W1. Right? Now in place of M1G, can I place W1? Yes, I can write W1. So 2W2 minus 2W1 by W2 plus W1 plus 2W1. I will take W1 as common. What I will get? 2W2 minus 2W1. And what is the LCM here? W1 plus W2 I can take as LCM. Okay. So first let us write this step and then I will write this step. First 2W2 minus 2W1 by W2 or W1 plus 2. Now let us take W1 plus W2 as LCM. What you will get? 2W2 minus 2W1 plus 2 of W1 plus W2. So W1, 2W2 minus 2W1 plus 2W1 plus 2W2 by W1 plus W2. Right? W1 strikes off. What you take? 2 plus 2, 4. W2, W1 by W1 plus W2 is the tension produced in the string when string is raised with acceleration G. So this question is asked in 2023, shift to May 13th. Okay. 3 questions I am saying. Now let us move for the next question. Alright. Let us move for the next question. In the pulley system, the mass of ball is 1 point to the mass of rod. Right? Mass of ball is 1.2 times the mass of rod. The length of rod is how much he gave? 50 centimeter. Okay. The ball is set on the same level as the lower end of the rod and then released. What is the acceleration of a rod? Okay, with which it comes down. Assume pulleys and threads are massless and friction force is neglected. Use G equal to 10 meter per second square. This is asked in 2020, shift to 9th September. Okay. Now let us go for the solution. Okay. Now here in diagram what he said. Now in such a way. Again I am drawing one pulley. Right. This is fixed pulley. Now one ball is there. Another end connected to this pulley. Now here 2 strings are there, you see. Now what he said in the problem, the ball correctly how he said? He said the ball at the lower end of the rod. The length of rod 50 centimeter. Right? The length of rod 50 centimeter he said. Okay. Now next, at the lower end of the rod, so ball is set on same level at the lower end of the rod. Okay. Now next what he did, he connected, he fixed another end of the string. He fixed another end of the string. Next in problem what he said that first the ball is set here, see. The ball is set on same level as lower end of rod in such a way. Again, he released it. Okay. Now he is asking, what is the acceleration of the rod with which it comes down? Now when ball is released, rod comes down. When ball is released, rod comes down. So he is asking what is that acceleration with which the rod comes down, he is asking. Okay. So for that, first let us draw the free body diagram. Now here you see it is fixed. Now here the tension will be T. Due to this rod the tension will be T. Now here the tension T plus T, 2T, summation of these 2 T's. Now as this is a same string, tension does not change. No, for same string, tension never change. Here same string TT. Now here same string, two strings are there. Here same string. So here if it is 2T, then here also it will be 2T away from the ball. Every time the tension will be away from the body. So away from the ball. Right? Now gravity. Let a small m be the mass of the ball mg. And here gravity, let us assume as capital M, mass of rod. Capital mg I rod. Right? Up to here clear? This is free body diagram. Now next, here first let us write the equation for ball. Here I am drawing the ball itself only. What are the forces acting on it? Here 2T, and in downward direction mg. Now in the direction of tension only we will have the acceleration. Correct? Now here in greater force is 2T. So ball is moving in that direction and rod is coming downwards. In problem itself he gave rod is coming in downwards. Okay. So rod, what is the acceleration of rod with which it comes down? He is saying no. So 2T is the greater force here. So what we will write? 2T minus mg, and according to Newton's law, m a. Now let us write for rod. On rod, capital mg force in downward direction. Now T is there here. T in upward direction. Now here rod is coming downwards. He gave in the problem. So mg will be the greater force. So acceleration will be along this greater force itself only. Okay. Sorry, here let us write the acceleration as A1 and let it be A2. Let it be A2. Right? So now how we will write? This will be the greater force. It is coming in downward direction. So mg opposite direction T minus T is equal to, according to Newton's law, capital M A2 I will write. Alright. Now here one is thread is uniform. Right? Here we are not changing thread. Here we are not changing thread. We are taking the uniform thread itself only. Right? And the length also we are not changing. The length of thread is constant. Okay? Uniform thread with constant length. So in such cases of constraint motions, okay, constraint motions, we call the motion, the system which is in equilibrium, we say constraint motions. So in such a constraint motions, for mass pulley system, the product of tension and acceleration remains constant. The product of tension and acceleration remains constant for constraint motions in mass pulley system. Right? So first, let us write this T dot A for this ball. What it will be? In place of T, you are having 2T. And A is in upward direction, so into A1. So here A is in downward direction, so minus. Here T is in upward direction. T, tension, and acceleration is A2. Now what he said? T dot A is equal to constant. No. Now I am writing 2Ta1. Here what is there? Minus Ta2 is equal to constant or 0. Or 2Ta1 is equal to Ta2. Tt strikes off. So now I can write 2A1 is equal to A2. Okay. 2A1 is equal to A2. One we got. What we said here, thread is uniform and length is constant. So such constant motions in mass pulley systems, the product of T dot A will be constant. So here the product of T dot A, in place of T you are having 2T into A1. Here A2 is in downward direction, so minus A2 into T I rod. As it is constant, we will get 2A1 is equal to what? A2. Okay. One we completed. Now next, from this, can I write A1 as A2 by 2? A1 as A2 by 2. Now I am substituting this. In this, put it as equation 1. Put it as equation 2. I am substituting that in equation 1. What is equation 1, beta? 2T minus mg is equal to m A1. So 2T minus mg is equal to m. In place of A1, what I said to keep? A2 by 2. Right? In place of A1, I kept A2 by 2. From here, we solved no. A2 by 2. Okay? A2 by 2. Now next. And now put it as some equation 3. Okay? Equation 3. Now next, multiply equation 2 by 2. So, multiply equation 2 with 2. What is equation 2, beta? First I will write equation 2 minus t is equal to m a2. Okay? m a2. So, completely multiply with 2. What you will get? 2 mg minus 2t is equal to 2 ma2. Okay, I multiplied it. Now after multiplying, put it as equation 4. Now after multiplying this, then add with 3. Add with 3. So LHS, LHS, RHS, RHS. 2t minus mg. So just keep correct concentration of small m and capital M. Small m is the mass of ball, capital M is mass of rod. Plus 2mg minus 2t is equal to m a2 by g, a2 by 2 plus 2m a2. Clear? Now anything is going to strike? Plus 2t minus 2t. Now what remained here? First I am writing the positive term 2mg minus small mg is equal to, here what remained, beta? Here ma2 by 2 plus 2 capital M a2. Right? So in question what he asked? He asked acceleration. So let us write this in terms of acceleration. mg minus mg is equal to m by 2 plus 2m into a2, a2 common. Now a2, I want acceleration. I have to find the acceleration. So 2 mg minus mg by m by 2 plus 2m. Right? Now, I am taking capital M as common. Okay? So, what I will get if I take capital M as common? G also I will take as common. Here, capital M. So, here I will get 2 minus small m by capital M. by, here also capital M I am taking common. So M by 2 capital M plus 2. I got. M strikes off. So A2 is equal to 2 minus M by M into G by M by 2 capital M plus 2. Right? In problem, what he gave, the mass of ball is 1.2 times greater than mass of rod, he said. Okay, the mass of ball is 1.2 times greater than mass of rod, he said. So M by M is nothing but 1.2 now from this. Now let us substitute. A2 is equal to 2 minus 1.2 M by M by 1.2, here 2 is there, divided by 2 plus 2 into G, what he said, use it as 10 meter per second square. So 2 minus 1.2, also what you will get, 0.8. Now here what you will get, 2.6 are, so 2.6 I will get, 0.6 plus 2, 2.6 into 10, right? Now what I will get, on simplifying, I will get approximately 3 meter per second square is the acceleration of produced in the string. Okay, when first we set the ball at the same level as lower end of the rod, again we released. When we released, rod is coming downwards. Okay, rod is coming downwards. Now he is asking to find the acceleration of that particular rod. So acceleration is 3 meter per second square. Hope you understood. Now next, let us go for the third problem in this video, the last problem on EAPCET machine asked in 2019, 4th May, shift 1. Okay. Now see, first let us understand the question. Okay. Now here, what he said, in the pulley system shown in the figure, the mass of A is half that of the mass of rod B. The rod length is 500 centimeter. The mass of pulleys and threads may be neglected. The mass A is set at the same level as lower end of the rod and then released. After releasing the mass A, it would reach the top end of the B in the time. Now what he said here, I am drawing. Now what he said, 2 pulleys hit. Okay. One end, he connected ball. Second pulley. How he connected? He placed the ball correct at the same level of lower end of the rod. Now next to this side, in diagram he showed, I am drawing the diagram, he placed another mass. Okay. Another end of this string is connected to this pulley. So 2 strings are there, 1, 2. Right? 1 string, 2 string. Okay. So now, first let us draw the free body diagram. Let us keep the names A, B, C. Mass of this you keep as MA, MB, MC. Right? Now next, tension due to MB, T. Tension due to MC, T. Same string, no? So same tension away from the bodies. T plus T, 2T. The summation of these two, here it acts. So away from the body. Now this is the same string, no, again. So here 2T means here also the tension will be 2T. Now here, when body is released, what he is saying, what is the time taken by the mass A to reach to the top level of the rod? Means mass A is coming in such a direction, no? So 2t will be of the greater force, acceleration will be in such a way, and this total pulley system, when this is coming in upward direction, this pulley system comes in downward direction. Complete this second pulley system will comes in downward direction. So here acceleration A. Okay. So now first free body diagram completed. First what he said, mass of body A. Body A is half of the mass of body B. So from this, what we will get? MB is equal to 2MA we will get. Right? First one completed. Next what he gave? Length of rod. How much he gave? 500 centimeter. 500 centimeter means 5 meters, no? 1 meter equal to 100 centimeters. So 5 meters. Now, in problem he talked about A and A only. A is, he is asking how much time will take by the A to reach the top end of the rod, he said. So, means here, by seeing this diagram, B and C are in equilibrium. Right? Are in equilibrium. Okay? When B and C are in equilibrium, then what happens? The mass of B will be equal to mass of C. Here, this is equilibrium system. Mass of B will be equal to mass of C. So now, let us apply the Newton's law to this and to this system. Right? To this system and to this system. So first let us apply to A. So when I apply the Newton's law to the A, now this is moving in upward direction, no? Means 2t is of greater direction. For mass, MA I am applying the equation, I am writing the equation. So 2t. So now here, what happens? Gravity force, MAG, acts in downward direction, minus MAG is equal to, according to Newton's law. According to Newton's law, this must be equal to MA into A. Right? MA into A. Okay. Now for this, we wrote the equation. Now keep this equation as equation 1. Put it as equation 1. Hope you understood. Now this complete pulley system is coming downwards. When this is lifted in upward direction, now these two are connected to the same pulley, no? Now pulley comes down, means these both also comes down, no? Now here we are taking, now as this is connected to the same pulley, we are taking the combination of these masses. Now in downward direction, in a downward direction, now in a downward direction, the gravity weight will be the combination of masses into G, that is MB plus MC into G. Okay. So now let us write the equation to this system only. Okay. I am writing the equation to the combination of this system. Okay. B and C. Now tension is in this direction. Now gravity will be MB plus MC into G in downward direction. Now it is coming in this direction, no? Downwards, no? So now what happens? This force will be great, no? compared to T. So, for mass B plus C, now how I will write? MB plus MC G minus T is equal to MB plus MC according to Newton's law into A. In place of M, I am writing the combination of MB plus MC. Clear? Put it as equation 2. Right? Now put it as equation 2. Now next, just let us simplify this using these two. This one and this one. So first, in place of MC, now afterwards let us keep the equation. In place of MC, I will substitute MB. So MB plus MB G minus T is equal to MB plus MB into A. So 2MB G minus T is equal to 2MB A. Right? Now in place of MB, right? In place of MB, I will substitute this 2MA. So 2, okay, first I will write 2MA G minus T is equal to 2MA. Sorry, 2 into 2MA. So this becomes 4MA G minus T equal to 4MA into A. Right? Another thing, correct only, no? 4MA. Sorry, here we are taking the complete pulley system, no? This is T, so this will be 2T. I'm extremely sorry. This is 2T. So 2T. Pulley system I'm taking, no? The suspension string will be equal to the summation of these two. That is suspended. This is the suspended string tension will be equal to the summation of these two tensions, 2T. So minus 2T. Sorry. Okay. Now clear. Put it as equation 2. Now add the equation 1 and 2. Okay. So this one and this one. LHS, first I will write 1, 2T minus MAG is equal to MAA. This is equation 1. And equation 2, 4 MAG minus 2T is equal to 4 MAA. This is equation 2. Now add 1 and 2. Right? Add 1 and 2. Now what you will get? 2T minus MAG plus 4 MAG minus 2T is equal to MAA plus 4 MAA. So plus 2T minus 2T strikes off. Now first I'm writing the positive term 4, or can I say 4 MAG minus MAG is 3 MAG. That is equal to 4 MAA plus MAA 5 MAA. Okay. Or now from this what I need? MA strikes off. I got acceleration as 3 by 5. Here G is there into G. Now G is said to take as 10. So 5 2s are. So 6 meter per second square is A. But what he said to find out? He said when he released the ball A, it comes to this upper end. So what is the time taken by the ball to come to the upper end of the rod? He said. So for that, let us use the formula ut plus half at square. There is no initial velocity. Half at square 0. Okay. So now we want t. So t square is equal to what happens? 2s by a, or the formula t is equal to under root 2s by a. Let us simplify. Now what is s? Now it is crossing the rod length, no? And what he gave the length of the rod? 5 meters. Nothing but it is crossing this distance of the rod only, no? So s is 5. A what we got? 6 we got. So 5 by 3. So approximately we will get 1.28 seconds, or approximately 1 second is the. So it is taking nearly 1 second to move from the lower end of the rod to the upper end of the rod. Okay. So this is about the question asked in 2019 4th May. Okay. Here what we did, MA he took equal to the lower end of the rod. Now here he connected B and C to different weights to the same string on another pulley, movable pulley. This is fixed pulley. This is movable pulley. Alright. Now he said he is releasing this. So from lower end it is reaching top. So first for this the free body diagram. Now here the tension assume as TT, same string. Now the tension of this is suspending string will be the summation of these two tensions, 2T. Now this is of same string, no? This is same string, no? Two strings here used. You see 1, 2. Now for this TT, and this is the suspended string for this pulley. For suspended strings, tension will be T plus T 2T. Now as this is of same string, here also the tension will be 2T. Here if it is 2T, here also it is 2T. Now free body diagram for A is, here it is coming in upward direction, no? So 2T will be greater. So 2T minus MAG is equal to acceleration. Acceleration is the same. Okay. Acceleration here for pulley and this we are taking as A only. Okay. Now next step. Here these two are in equilibrium. Okay. These two are in equilibrium. Here when the body comes up, this complete pulley comes down. This pulley comes down. Pulley is coming down means to that pulley only we connected MB and MC, no? So they also come down. So we are taking this as a combined system. Okay. So combined system and writing as the downward force MB plus MC into G. And as it is coming downwards, this force will be greater than this 2T. So we are writing this as MA MB plus MC into G minus 2T is equal to MB plus MC into A. Now we substituted MB in place of MC. Okay. And we substituted 2MA in place of MB. We solved it and we got the answer as 1 second. So thank you for watching my video. If you like it, share it, subscribe it and stay with my channel for more PYQs of EAPCET. Thank you.